Hello, good morning, everyone. My name is Chris May. I am the open source solutions advocate at Sangoma. Welcome to final day of AstriCon virtual conference pre-track. Today we have a presentation on VoIP test automation by Nikolai Shakin. This presentation explores the importance of VoIP systems testing and shows how Asterisk can build effective VoIP testing systems. Topics include integrating Asterisk tests into CI/CD pipelines, end-to-end functional testing, and scenarios like registration, NAT client emulation, call generation, caller ID management, PBX logic, and IVRQ validation with live demos. It also covers using Python AMI, the Asterisk Manager Interface, containers, and monitoring tools such as sngrep, Homer, and Prometheus to analyze results, plus alternatives like SIPp and Sipsak. Resources and code snippets are included for reference. About Nikolai, he's a seasoned VoIP developer with over 12 years of experience working with Asterisk. From 2017 to 2022, he shared his expertise by teaching a dedicated course on Asterisk. Currently, he works as a VoIP developer for a SIP provider. Nikolai has also been a frequent speaker at AstriConf, the Russian counterpart of AstriCon, where he has presented on numerous occasions. With that said, very warm introduction for Nikolai. Very excited for this presentation. It is quite technical. Please know that afterwards you'll be able to watch it on YouTube and hit pause, but it's a lot of it great information. So really looking forward to it. Nikolai, I'll turn off my camera and hand it over to you.
Okay, thank you. Thank you for having me today. I'm really happy to be here. So, as Chris said, I'm experienced voice engineer. I work with Asterisk since 2009, I believe, and I'm really a fan of Asterisk. Now I'm working in VoIP MS, that's a Canadian SIP provider, as a voice developer. The topic I'm going to cover today are generating SIP registrations with Asterisk, generating call, generating high CPS load with Asterisk, concept of end-to-end testing in VoIP systems. We will briefly cover observability during the tests and alternative SIP testing tools that you might need to use if you can't to achieve your goal in testing with Asterisk. Let's start from the basic one. It's registrations. Registrations is common thing to test, and usually it's enough to just have one registration with your soft phone or your hardware phone, but it doesn't match your needs when it comes to scale. And Asterisk here can be both a voice service and a tester. It's easy to configure, it's easy to integrate in your automation pipelines, and it's fast to reconfigure if you need. I believe it's a pretty simple thing. Everybody knows that Asterisk can create outgoing SIP registrations, and the configuration for that is pretty straightforward. You need to create transport in PJ-SIP, you need to create a registration section, and you need to create authentication section for this registration section. That's pretty straightforward, and this is kind of the minimal case. You already, with this configuration, can check if your service accepts registrations, and you can play with it. But testing is all about big scales, because you need to test your SIP system in scale. It's not that efficient to test just one your service with just one registration. And usually we need to create tens or hundreds or even thousands of registrations. And it's pretty easy with Asterisk as well. You just need to create more sections, more registration sections in your configuration file. And usually I use Ansible for that, because Ansible not only provide you tools for creating configuration files, but also it allows you to run tests or execute some actions inside the same script, inside the same playbook. We will not dive into details how Ansible works, but you can see that we have a loop here, and we loop through the list of users, and we create for every user's registration section and authentication section. And let me show you how it works in practice. I have 3 screens here. This one, the brown one, is my local host, is my laptop. I'm going to use it for executing Ansible playbooks. This one, the white one, is my SIPp service. You can understand it here in the bottom left corner. You can see the name of the host I connected to. This is an Asterisk instance that is going to be our SIPp service. It emulates our SIPp provider. As you can see, now it's empty. The configuration file pgsipconf is empty, and we almost don't have any traffic. Some bad guys trying to scan us, but that's not our intended traffic. Okay, and I have another host here. That's SIPp service again. I will close it, and I have another host here. That's our SIPp tester. This is the machine I'm going to use for creating tests, for conducting tests. This machine is going to create load for our SIPp service. And this machine doesn't have any configuration as well. Here I am in Asterisk CLI, pgsip show, I don't know, transports. You can see that there is no transports here, so Asterisk is not configured yet. Okay, let's move on. For now, I need to generate configuration for our SIPp service first, and then for our tester. And I'm going to create 1,000 users on our SIPp service. I have already code snippets to do that, and you can find them in the repository. I will share the link in the end of the presentation. This is how Ansible works. Basically, you run a playbook and it executes a few actions. In our case, it creates configuration file pgsip.conf and it restarts Asterisk. Let's go to our SIPp service and see what's going on here. As you can see, now we already have some configuration, and this configuration actually is quite big. So it's 20,000 lines or something like that of configuration, and we basically can see that we have pgsip show context. We have even some context here already. Oh, it's probably from the previous registrations. SIPp show pgsip list endpoints. No, Asterisk was not restarted. Now we can see that we have 1001 endpoints here, and we can actually create now registrations from our tester. And I have a different playbook for that. It will connect to my tester server and it will create pgsip there with multiple registrations. And yeah, you can see that the playbook just restarted Asterisk here, and you can see multiple registrations happening in sngrep. This is a tool for catching SIPp traffic and showing it like in those nice flows, in those nice graphs. Okay, so what we did, we actually created 1,000 registrations, and they seems work. You can check it here. PG-SIPp show registrations. You can see 1000 registrations and all of the users registered, everything worked fine. And we can see here that we have multiple PG-SIPp list contacts. We have 1000 new contacts, which is our registrations. And in SIPp trace, you can find those registrations. That's nice already. So we just checked that all of our 1000 users can register on our SIPp service, which is quite a big task if you need to check it. And you don't use some automation tools, for instance, Asterisk or CPP or something like that. Okay, let's move on. What we can do next is we can improve our tests, because for now, as you can see, we have very ideal traffic. All the registrations came from one socket, and that's not really what we usually see in real world, because we have multiple clients and every client uses their own IP address and port. And we have very ideal contact header here. If you see inside the registration, when users send us registration, they form contact header equals to the username, which is not the case in real world, because in real world, users can provide whatever they want here in contact header. And sometimes due to misconfiguration or for some other reasons, they provide really crazy things here. So our goal to have efficient tests, our goal is to spoil the traffic a bit. And another thing that you might need to modify is to make Asterisk a bit ruder. So Asterisk, out of the box, it's very polite system. It will not try to re-register if you refused registration, and it will keep long pauses between tries. And basically, you need to modify those parameters to make it rude, to make the traffic intensive during the test, because that's usually what we want to. And we need to spoil traffic. As I said, we need to create bad contact header. We might need to create random expires periods, and we might need to create random user agents, because it's common thing, especially for public SIPp services, when you have some kind of filtration in the entrance and you don't want to allow bad user agents to access your system. How we can do that? Basically, Asterisk provides us this opportunity out of the box, and we just need to add a few things here. We can create the user agent field, and we can choose randomly from the list here. We can choose user agent, and the most complicated part here is we create separate transport for every our registration. What it gives us, we kind of emulate a unique socket for every user. We cannot use different IP addresses. However, we can use different ports for every registration. And let's try it in practice and see what will happen. Basically, I will run the same playbook but without nice mode, and it will create new configuration, and it will restart Asterisk here on my tester machine. As you can see, I was disconnected from CLI. That means that Asterisk was restarted. And you can see that I have new dialogues. And the first thing you can notice here is that we already have different ports. When we send registrations, every time we send it, we use a separate port, and that creates unique combinations of IP address and port for our registrations, and that emulates uniqueness of sockets for registrations. Let's see if we have all registrations in place. PJSIP show registrations or list registrations. Yeah, we have a lot of them, basically 1000 registrations, but this time every registration has a unique expiration time, and it has like some unique parameters here. Let's compare if you just random registration packets and see what is the difference. As you can see, they are different. They have different expires, and we take expires from the range 10 to 4000, and they have different contact header, differently formatted contact header. This is kind of normal with no letters, but this one starts with S. And we should have different user agent, and we have this one is stressor and this one is ground stream. So, and those user agents, they came from this list of user agents when we formed our configuration file. That's a bit better. I mean, a bit worse, but in our case, it's a bit better that we have not that ideal configuration right now. Let's go back here. That's interesting. As you can see, we have registrations on our service here, and registrations came from different ports, and so this traffic is going to be much more realistic. But for some reason, Asterisk hasn't updated the contact headers here. Maybe we found a bug right now. I will just re-register all the users. It shows the same picture. That's interesting. To be honest, I have no idea why it happened, but new registrations have not rewritten the old ones. So we have registrations, we have contacts from the first try, but that wasn't the purpose of this presentation. The idea was to show you that you can create registration from different. That's basically a problem of our SIPp service, that it doesn't update the contacts, and that's why we have those tests. As you can see here, we send registrations from multiple from multiple ports, from unique sockets for every registration, and every registration has its unique contact and its unique tester and expires. Okay, let's try. Let's move on. This is how you can create multiple registrations, and you can basically check if your SIP service handles the load properly and can really serve your clients in a scale. The next topic is how to generate calls, because like we created registrations, but when it comes to generating calls, we have the same method by testing. And actually, I often use this way. I have a soft phone, and if I need to create one call, probably I will use my soft phone. But when you need to do it in scale, you need to do it in a different way. And the way I prefer is using Asterisk with originate function. This function is kind of a way of generating calls. How it works? You can generate a call with originate with Asterisk CLI. And when you ask Asterisk to originate, it first calls some channel, and after the channel answers, originate will connect this channel to some application and will play back, in our case, the whistles. So the syntax is pretty straightforward. Channel originate, the name of the channel you want to call, the application, that's a mode of originate, and play back. In our case, TT whistles, it's an argument to a playback. Okay, so this is how we can generate a call in Asterisk, and the easiest way to generate the call is use CLI command. It's not the very efficient way of generating calls, but it's still possible. Let's try, for instance, we have multiple registration. Oh, guys, I forgot. Due to this strange situation, I forgot one thing I wanted to show you about registrations. Let's come back here. One thing I didn't show you is about creating this NAT, reproducing this NAT issue. Usually in real life, if you have a SIP service, most of your clients are going to be behind NAT, and your service need to process those calls properly. And what you can do to create this system, this situation, is you can basically build your virtual network with a router with NAT, but in most of the cases, it's overhead, and there is a simple way to do the same thing, but without creating networks or stuff like that. You can run Asterisk inside Docker container, and Docker container out of the box has NAT. So you can basically, I will stop Asterisk, which is running directly on my machine. Or stop. And I'm going to run Asterisk with the same configuration file, but inside Docker container. You can use whatever container you want. You can use any container you want. I use for this test this one. And we connect our local directory with configuration files to the container with -v key. And you can see that container is running now. And you can see that we send multiple registrations, but this time the source is not our external IP address, but our internal inside Docker IP address. And basically, this is what we wanted to have. When we send packets, we form incorrect contact header because Asterisk inside the container, it doesn't know its real IP address, external IP address, and it creates this bad contact header. And I hope Asterisk will now show us. Yeah, now we have those bad contacts here, and they came from unique IP addresses, from unique pairs of IP address and ports, and they have a bad contact header inside. So Asterisk needs to handle the situation correctly. That was one point. And let's come back to call generation. As I said, we can use Asterisk to generate the call with originate. And the simplest way to do so is to create originate. Let's say we have registered user. It was deleted. Let's say 1999. It thinks that it called this extension, but for some reason it didn't create invite. That's strange. Probably I have some issues with my SIPp service. Maybe it was hacked before the presentation has started. Okay, but let's try to generate call from different place. Let's try to generate call from here, from our tester machine. I will stop the container first. And let's say we want to generate call. I'm gonna use my code snippets I prepared before. And we can call some number. As you can see, Asterisk started executing something, and I hope we will see invite. Yeah, we see invite here. Asterisk send an invite to our target host just by issuing the command. And in most cases, that's what we want to have. That's interesting what's going on to this machine. Okay, I will find out later. So with this CLI command, you can generate a call from Asterisk to your SIPp service. And that's a pretty straightforward way. It's easy to use because even if you have never used it, in Asterisk CLI, you can press tab and have auto completion to help you to create this channel originate. And if you press enter, you will see the kind of short documentation on how to use this channel originate command. But usually we need to have more than just one call generation. We need to generate multiple calls. Let's say I want to generate a call every 200 milliseconds. I can execute this command watch minus n, and with n I provide interval, and every 200 milliseconds I'm going to execute this command, which is basically the command we used before for call generation. And if you need to generate up to 10 CPS, you can use the watch, because the minimal interval for watch is 100 milliseconds. But you can do better. If you need more CPS to generate, you can use while loop with bash and do the same thing, and you can customize it. You can provide sleep interval. You need to have to have more precise CPS. But the problem with this is you cannot achieve high CPS, and if you need CPS more than, let's say, 70, this is not the proper way. You need to use Python or something else, and you need to. And another disadvantage of using this asterisk CLI command is when you generate a call this way, the call is going to be from anonymous. And in some cases that's okay, but in most of the cases we want to have something more meaningful in caller ID. And how you can solve this issue, you can basically do it with a dial plan. And when I showed you the example of usage originate, basically I didn't have anonymous here in from header. And this is because I have configuration in my extensions conf. I have this configuration, and I set, before I call the channel, I set the caller ID number. I could set whatever I wanted. And it makes the command a bit more complicated. When you originate the channel, you do not originate like pgsip / whatever you want, but you call a local channel, and this local channel refers to some place in dial plan. In our case, it's context called testing, and extension, whatever you want, any digits, and that's basically it. After we connect to this place in dial plan, we are going to wait for 10 seconds in our case. This is how you can solve the problem with anonymous caller ID using dial plan. But the most efficient way of doing so is to use AMI interface, Asterisk Manager interface. Though there are a few options, except of those is creating call files or using asterisk REST interface, or ARI. And let me, if you have never used asterisk manager interface, let me explain briefly how it works. It's very simple. Asterisk opens port 5038, and you can connect to this TCP port with any tool you want, and you just send a text there to this socket. Asterisk will handle this text and will originate. Basically, you can see very similar syntax as we used when we generated calls with CLI. You can see basically the same fields, but you can provide caller ID right away here when you generate a call. You do not need to create those supportive dial plans to set caller ID. And the benefit of using AMI is you can generate calls in a more efficient way, and you can achieve higher CPS. And another benefit is you can have like feedback from Asterisk, because Asterisk can generate messages, what's going on, events, what's going on inside Asterisk, and send them back to AMI interface. But in the most simple scenario, we just need to configure manager interface with this configuration file, and we need to connect to socket. The simplest way to do so in Linux is to use netcat command, localhost, and port, and we send to this connection the following test, and it will generate a call with AMI. What That's basically main idea behind generating calls. So you can use either a CLI command and the bash script, because that they match the best, or you can use a Python script. Like I have an example here. You can do the same thing with Python. And in this case, you can generate more calls because you can connect once and you can send multiple calls there. Okay, let's dive into end-to-end testing. When we need to test some SIP service, we usually need to check multiple points. Can we reach them, and can we reach them using the specific set of caller IDs? Can we reach the specific set of destination IDs or destinations in our PBX or SIP service? And the problem here is it creates very many scenarios, and it's impossible to test it manually, and we need to use some kind of automation. That's the first problem. So we need to do it in scale in different combinations and check that everything is working correctly. But the most interesting problem here is, how do we understand that the call was successful? As you saw, we can generate calls, and it's not that hard. Basically, it's executing channel originate command on Asterisk. But how do we understand that the call was successful, that we processed the call properly? Let's remove configuration from my SIP server, and we'll try. Actually, we don't need to do that, but just in case it behaves strange, so I would like to restart it. Okay, and I will need to clean configuration here as well to do not create those registrations, because they are not available anymore on our SIP service. Okay, so we need to check if our SIP service is working nice and correct. What's the common problem with SIP servers? When you have a complicated dial plan, you can have the situation like this. For most of the calls, we have correct scenario, which is just playing beep, then playing tones, then wait for 5 seconds, and then hang up. But for some reason we have a couple of bad destinations, and it's hard to find because this is kind of a template, and almost any number matches this template, but we have only two bad numbers, and it's hard to find them inside the whole dial plan, yeah, of our asterisk. And how we can do that? We can do it with the simplest way to do so is to use dial plan. And in dial plan, we can check, we can dial extension, and after we dialed it, we check the dial status. If the call was answered, we consider the call was okay and it was successful call. Otherwise, we consider that the call failed and it wasn't successful. And we can basically do grep error here. I connected to Asterisk console. This A is alias for asterisk minus R VVV. And now I want to generate a few calls. Let me clean my sngrep. And where is my code snippets here? I would like to check 300 extensions if they are answering or not. That's my idea. That's the idea of my test. Let's execute this command and see what's going on. You can see that Asterisk generates multiple calls, and all those calls, they are basically friendly scanning the range from 1000 to 1300. And you can see in the output, we have some errors. Those are basically performance issues, I believe, because I do not use sleep between originates, and this is a problem of performance of this specific machine. But the thing we are interested in is this line. So we know that when we called extension 1111, the dial status was busy instead of answered. And we can see it here in our trace, SIPp trace, that when we called the number 1111, it answered with busy. And this is how we found this extension, this bad destination. But in many cases, it's not enough because we want to have better understanding of how the calls routed in our system. For instance, we couldn't understand that here we had a problem. And what we can do to define those things and to test sophisticated routes, or if you need to define when you have a fake answer, if you are using some pstand providers, they can route the calls not to your legitimate user but to some fake destination, and then they will charge you for this call. And for those cases, it's not enough just to understand if the call was answered or not. But Asterisk provides us tools to handle this issue as well. What we can do, we can add some extra check. Asterisk provides you opportunity to, it gives you tools to generate some tones, some signals, and it gives you tools to recognize if we have some signals in the line. And what we can do here, we can set, for instance, if we're talking about testing IVR. In this case, when we came to T destination, we can, oh, that's a mistake here, it should be I destination, but okay, you see, I believe you will understand the idea. When we come here, you play one signal. When you come here, you play another signal. And when you come here, you can basically call some different instance of Asterisk, and you can generate another signal there. So every destination in our IVR is going to generate some unique signal. And that's basically what we see here in the dial plan. When I play back beep, I not only play back this beep, but I generate a tone. This construction will generate tone on the frequency of 1500 during 300 milliseconds. So it will generate the signal for 3 seconds. And Asterisk can recognize this signal with an application called wait for tone. And here I am telling to Asterisk that if you hear 1500 hertz during 500 milliseconds, and this is timeout 3 seconds, we will consider the call is successful. Otherwise, we don't get the tone, and we consider the call as failed. And basically, we can use this to test more complicated scenarios. Let's try to do it again. This time, our originate construction is a bit different. So we do the same thing, channel originate. We call some local channel and connect it to testing context here. Basically, we already saw that. And after that, we connected not to application, but to extension, extension S in context detect tone. And this is this part of the logic where we define if we got to the signal or not. Let's try and see how it's going. That was the first error about dial status, that we didn't receive dial status, and that was the second error. So we found both bad extensions in our SIPp service by using, we didn't use any soft fonts or any hardware fonts. We just used Asterisk to do so, and we don't even know what was inside those channels, but we know that they are working incorrectly in this case. And that's basically a framework you can use if you apply some changes according to your needs. You can use this framework to test any SIPp service you want, and it's very flexible and it's very convenient way. And one thing from VoIP MS, that's a company I'm working for, when I asked about a vacation for this presentation, they provided for all the participants free $15 for their account. So if you are a participant of our virtual track of Asterisk, you can pin marketing at voip.ms with a topic with a subject AstriCon, and they will give you a promo code for getting $15 free for your test. So it's always a good idea to have independent VoIP service with DID numbers you can use for your test or whatever you want, or you can just pin them on LinkedIn. Here is some tools from Asterisk that you're going to use when you are testing things. They are kind of useful, send DTMF or tone detect function. We don't have time to cover them, but I believe you can understand what they are for. We almost don't have time, but let's speed up. About observability. During the test, it's crucial to have an opinion about what's going on your Asterisk, to have information about the state of your Asterisk. And the most straightforward way to get this information is to use Prometheus module. So Asterisk out of the box has Prometheus module, and it's easy to configure. Basically, that's all the configuration you need to do on Asterisk. And this is configuration you need to do on Prometheus side. And it's easy to run. You can run it in Docker container by executing this command, and it's going to give you information about current state of your Asterisk instance. And this picture here represents dashboard not on Prometheus, but in I forgot how to call it, in Grafana. But this is kind of ready template out of the box. If you have data in Prometheus, you can easily use this template in Grafana to create this dashboard. And the one thing I don't have a slide for is you always need to think about how you will interrupt your tests, especially if we're talking about high CPS or stress tests. How will you interrupt your test if something went wrong? For instance, you see here that your CPU load is 100% and you want to stop the test, but you lost connection to your SSH session and you cannot stop it. So it's always it's always a good idea to have the red button you can press to interrupt your test. Let's go to tooling for observability. The tool I showed you before, and this very convenient one, actually that's my favorite one, is sngrep. You can find it on GitHub, and it's available in Debian repositories out of the box. It's really a convenient thing. As you saw, you can do a lot of things there. Another tools more serious, let's say, it's Homer or SIPp3. What are they doing? They allows you to collect SIP traces from multiple points, and they can build you some graphs, interesting analytics, and it's really useful when you're testing something. It's really useful to see those graphs. You can understand a lot of about your system, how it handles high loads by analyzing those graphs if you have some. And the last part of my presentation is about alternative SIP testing tools. There are a few of them I use. The first one is SIPwishes. And at the beginning of the presentation, you saw that someone tries to scan my SIP service with this tool. This is a tool basically that allows you to scan security issues on your service. It can scan SIP servers, it can scan the range of extensions, and it can brute force passwords. Another tool is Sipsak. That's a very convenient tool for multiple purpose. I often use it just to check if the service is available. If I need to send SIP option fast, I usually use this tool. SIPp, that's in my opinion the best tool for SIP testing when it comes to high CPS, when you need to test some intensive modes for your systems. That's the best tool. It provides statistics and it's very flexible, but it's a bit complicated to use. FreeSwitch or Chameleon. Those two allows you to emulate upstream providers and respond with different answers. So you can create some non-standard situations and see how your system will react when upstream provider answers unpredictably. iPerf, that's a tool that allows you to generate large amounts of traffic when you need to just flood, for instance, your SIP port and see how the system handles it. Basically, you can simulate DDoS attack with this tool. And SIPxr, that's similar to Sipsak tool, but it's more powerful, more flexible, and it allows you to use WebSockets. So you can use it for testing WebRTC applications as well. As I said, you can find code snippets I used in this presentation on GitHub, and you can find this presentation by following these links. If you have any questions, you can pin me on Telegram or on email. And if you have some questions, I'm going to answer them right now. So if you have something to ask, please do.
Thanks, Nikolai. That was a really great presentation. I enjoyed all the different tools that you make use of. It's there's a lot. They seem look around and there's even more every year for SIPp. I really enjoyed your Ansible playbooks as well earlier to generate a lot of the Asterisk configuration files. I find myself doing that often as well, but in a more structured manner. I had not utilized the random command. Maybe I had, but not too often. I usually am using Ansible for a reproducible situation, and it is reproducible in this way, but excellent to have some random work in there with the different UAs and whatnot. So really great work. Thanks for that. Also, as a reminder, we'll have this on YouTube so you can, pause and review. I myself took a lot of screenshots during the presentation. So I guess we'll take a look. There's, some questions. Feel free to put those up in the chat. I guess I had a question on the remote tones. In that sort of situation when you're dealing with some, let's call them shady routes, maybe. What sort of tones are you looking for? Is it a country-based ringtone, and so you're
No,
sort of
no,
looking
no.
at? Okay.
Let's say we need to check if we have fake answer.
Mm-hmm.
Here's let's say we want to check if we don't get fake answers here. What we do, we call through this suspicious PSTN provider. We are calling to our Asterisk instance. So
I see.
we
Excellent.
we are actually controls this instead of this user. We are using our Asterisk, and this Asterisk generates whatever we need. And actually, to be honest, in most of the cases, this is the same Asterisk that generates the call. So you can you can create kind of a loop from here to here, and you're bringing back this call. And it's especially convenient when you use AMI connection. You can see when this call came, and you can do a lot of stuff there by using this information. So it's pretty convenient tool.
Very well. I can see. Yeah.
Sorry,
Yeah. Go ahead.
sorry. I wasn't sharing my screen. I was.
Oh
I
no,
was
it was.
showing.
I had it in my head though, the picture of it, and it was great. So that's a great way to do it. Yeah.
I will show you one moment.
Okay.
Because I
Yes.
draw the picture. So
Ah, there we
basically,
are a bunch of times. Okay, I'll turn off my camera. All right.
basically what I was telling about. So instead of this user, we have some specific number we are calling to, and this is an Asterisk instance, and we can control which tones we are generating here. And actually, we're using the same box here. We don't use a separate Asterisk. In most of the cases, it's like that's the best way. You just forward this call back to your initiator, and you can understand what's going on there. That's the idea of the test.
Very good. That makes a lot of sense. We've got just a few moments left here. I'll just say thanks again to everyone for watching. We will have another session coming up shortly. Please come back for that. Nikolai, thanks so much again. Hopefully we can see you soon at an AstriCon in real life. This is a great presentation. Appreciate the live demos. Everyone, you've got Nikolai's contacts. I think occasionally I've even gotten a patch over there, maybe, but on some projects that he's worked on, very prolific on GitHub as well. So thank you for your time. Thanks everyone for participating, and we'll look forward to seeing you soon.
Thank you for having me today. Have a great day.
Bye bye.
Bye, guys.